where Harvard and Yale, or the New York Times, to skip over to another kind of institution, they're institutions that have value because people say they have value, right? It's that simple, right? I, having been to Yale, I can say that it has really, really minimal actual value. There's no question in my mind that the value that it has is.
I think when you're saying things like this, that's not what you're not even supposed to say this.
Why?
Well, because if they have value because people say they have value, then if someone like you says the things you're saying right now, that's undercutting what other people are supposed to say.
Right. Well, that's the whole point of this. That's why we're here. I don't mean to freak you out, but that's exactly what I want to talk about.
Because of the success of science, there is a kind of I think a kind of pseudoscience that social science is an example of a science which is not a science. They don't do scientific. They follow the forms. You gather data, you do so and so forth, but they don't get any laws. Haven't found out anything. They haven't gone anywhere yet. Maybe someday they will, but it's not very well developed. But what happens is, at an even more mundane level, we get experts on everything that sound like they're sort of scientific expert. They're not scientific. They sit at a typewriter and they make up something like, food grown with fertilizer that's organic is better for you than food grown with fertilizer that's inorganic. May be true, may not be true, but it hasn't been demonstrated one way or the other. But they'll sit there on the typewriter and make up all this stuff as if it's science, and then become an expert on foods, organic foods, and so on. There's all kinds of myths and pseudoscience all over the place. Now, I might be quite wrong. Maybe they do know all this thing. But I don't think I'm wrong. See, I have the advantage of having found out how hard it is to get to really know something, how careful you have to be about checking the experiments, how easy it is to make mistakes and fool yourself. I know what it means to know something. And therefore, I see how they get their information. And I can't believe that they know it. They haven't done the work necessary, haven't done the checks necessary, haven't done the care necessary. I have a great suspicion that they don't know, that this stuff is, don't know, and they're intimidating people by it. I think so. I don't know the world very well, but that's what I think.
You got these guys in the physics department and the math department, and they have all kind of complicated theories, which of course we can't understand, but they seem to understand them. And they have, principles, and they deduce complicated things from the principles, and they do experiments, and they find either they work or they don't work, and that's really impressive stuff. So I want to be like that too. So I want to have a theory in literary, in the humanities, literary criticism, anthropology, and so on. There's a field called theory. We're just like the physicists. They talk incomprehensibly, we can talk incomprehensibly. They have big words, we'll have big words. They draw, far-reaching conclusions, we'll draw far-reaching conclusions. We're just as prestigious as they are. Now, if they say, well, look, we're doing real science and you guys aren't, that's white, male, sexist, bourgeois, whatever the answer is. How are we any different from them? Okay, that's appealing.
It sounds as if your work draws a lot on C.W. Mill's, Marx, and Immanuel Wallerstein's thinking. And I'm wondering, what's new and exciting about Chomsky theory? So for us students of the social sciences in the room, what can we take away from this lecture?
Yeah. Well, certainly not. It's basically, first of all, there's no theory. In fact, I don't know of any theories in the social sciences. I don't think the term theory should be applied to fields as intellectually thin as the social sciences. So there's no theory. There's just some common sense observations. I started off, if you remember, by saying that views of this kind are commonly described as Marxist, which is kind of ironic because the clearest articulation is people like Adam Smith and Winston Churchill and so on, which is true. And I think that most of this is kind of common sense. So
if there's no theory, what's the point then?
Oh, the theory is very different from understanding. Most of our lives, we live our lives often pretty successfully without any theories about other people. We don't have any theories about other people, but we get along and manage our interactions and so on. There's very few areas of human life where there's anything you might call a theory. So some areas, like even in biology, it would be, but when you get very far beyond big molecules, it starts to become pretty descriptive.
Sure, but
in the world of human affairs, I don't think there's much in the way of theory. I think the message you ought to take is use your sense. Look at history, think of obvious things, break through the propaganda images. Remember that the institutions are trying to indoctrinate you. Keep that in mind, compensate for it. And if you do these things, I think you can get as good a sense of the world as anybody has.
Thank you.
Peer review is a cancer from outer space. It came from the biomedical community. It invaded science. The old system, because I have to say this because many people who are now professional scientists have an idea that peer review has always been in our literature, and it absolutely motherfucking has not.
Right.
Okay? It used to be that the editor of a journal took responsibility for the quality of the journal, which is why we had things like Nature crop up in the first place, because they had courageous, knowledgeable, forward-thinking editors. And so I just want to be very clear, because there's a mind virus out there that says peer review is the sine qua non of scientific excellence, yada, 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 bullshit, bullshit, bullshit. And if you don't believe me, go back and learn that this is a recent, invasive problem in the sciences.
Recent invasive problem that has no justification for existing in light of the fact
that not only does it have no justification for existing, when Watson and Crick did the double helix, and this is the cleanest example we have, the paper was agreed should not be sent out for review because anyone who was competent would understand immediately what its implications were. There are reasons that great work cannot be peer reviewed. Furthermore, you have entire fields that are existing now with electronic archives that are not peer reviewed. Peer review is not peer review. It sounds like peer review. It is peer injunction. It is the ability for your peers to keep the world from learning about your work.
Keep the world from learning about your work.
Because peer review is what happens, real peer review is what happens after you've passed the bullshit thing called peer review. The key problem is, if you go back to our original contention, which is that there is something universally pathological about the stories that every institution predicated on growth has to tell about itself when things are not growing. The biggest danger is that somebody smart inside of the institution will start questioning things and speaking openly. And it seems like
the polymaths would be the people who could connect the dots and say, there's not that much going on in my department. There's not much going on in this department over here. Not that much going on in this department over there. And those people are very, very dangerous. One of my friends studied physics at Stanford in the late 90s. His advisor was this professor at Stanford, Bob Laughlin, who, in the late 90s, brilliant physics guy. Late 90s, he gets a Nobel Prize in physics, and he suffers from the supreme delusion that now that he has a Nobel Prize, he has total academic freedom and he can do anything he wants to. And he decided to direct it at, there are all these areas you probably shouldn't go into. You probably shouldn't question climate science. There are all these things one should be careful about. But he went into an area far more dangerous than all of those. He was convinced that there were all these people in the university who were doing fake science, who were wasting government money on fake research that was not really going anywhere. And he started by investigating other departments. He started with the biology department at Stanford University. And you can imagine this ended catastrophically for Professor Laughlin. His graduate students couldn't get PhDs. He no longer got funding. Nobel Prize in physics, no protection whatsoever.
And maybe the way I think about COVID is a good example of the way these things go wrong. So basically, that view of the world says when the public has to make decisions about virology, who are we going to call? And the oligarchic answer is, obviously, we are going to call the virologists. Oh, what, are we going to call your aunt in Iowa? What? Right. Excuse me? The one I saw from the plane at 30,000 feet? Are we going to call the people at the rodeo? No, we'll call the virologists, right? I got it. I'm brilliant, right? So, this was their answer. And this is a 20th century answer. This is, the idea of basically just delegating without any accountability, responsibility for important decisions to academics basically kind of dates mostly to the Woodrow Wilson era.
Yes.
So, the progressive era with a capital P, it's about, and this is when basically America's, so if you see like description of the Gilded Age, like, go to an old American city, see all those like brick buildings and like, beautiful old stuff, all of like DC, all of that is built in what we call the Gilded Age, which is a period when America was governed very much the way China is now. It was very corrupt. Politics was this incredibly sordid, screwed up business. Shit got done.
Yes.
Shit got done in a corrupt way with people stealing a bunch.
Yep.
But did shit get done at enormous velocity, really fast, all the time, in the physical world, not just building some goddamn software? Absolutely. Right? Look at the way they built the Empire State Building. Right? This is the world that built the Empire State Building. So, and at this time, America, like China, is a third world country. It's culturally insecure. It does not have, before World War I, it's like, it's a peninsula of Anglo-American culture. The center is in London and has always been in London. The center of finance is in London. America is the periphery. American intellectuals look at this and they're like, we should be the future. Look at a map. And what we actually need is essentially, and you'll see this written very, very explicitly, for example, in Walter Lippmann, who I'm sure you've read.
Yeah.
Right? And what America needs is basically a new class of Platonic guardians. A new class of basically people who are sort of, just are not these like sordid, stealing politicians. Like, so this comes out of people like Henry Adams, for example.
Yes.
Who's like this like fourth generation super, he's like, from this amazing political dynasty. He's like the intellectual leader of America, as the editor of the North American Review, which was like the New Yorker of its day, but better. And he's basically like, that whole world of old money and old wealth is like, no, actually, this isn't working. And the new world will be a world of science. And it needs to be guided by science, and it needs to be guided by expertise. What comes out of that is the invention of sort of all these social sciences, which are really sciences of government, or probably in most cases pseudosciences of government, because they don't actually seem to work out very well when you try them, which is a thing that normally...
Sociology, psychology.
Yeah. And so, all of these things, so you get sort of all of these sciences that are basically sciences of government and sciences of how the government should do something. And once sort of any kind of governing power, whether it's the people or a king or anything other than an oligarchy, decides that the oligarchy has the last vote, and it's the oligarchy's opinion that counts, and basically delegates it to the experts, the scientists, the mandarins, the priests, whatever you call them, you've ceded power to these people.
And then
and the consequence,
democracy's done at that point.
Oh yeah, democracy. Yeah, remember my two no's, right? It isn't and it shouldn't be, and it can't be. And the American people just simply don't have the power to do that. They don't have the energy. They don't have the knowledge. They don't have the energy. It's not a question of even whether they would do it well or badly. They would just do it weakly, and power would be instantly ripped from their hands. It would be like having an absolute monarch who's like 6 years old. There's no way this kid, even if he's the rightful king of France, is actually the king of France.
Right.
So, his best choice is to use whatever power he has to make sure some guy who's not molesting him is the king of France. That's basically where we are, right? Sorry, that was a little coarser than my usual analogy.
So good.
But
let her rip.
Yeah, let her rip, right? And so the problem is what this does to the experts. So it's like you basically have this pool of expertise. You have this network of expertise. And if you have a network of expertise in something that has no possible effect on power at all, like astronomers, you'll look at American astronomy and you say, has this been corrupted by power? Have astronomers, is there a woke astronomy? Not just woke staff practices in astronomy, but like seeing like constellations that aren't there, making up like new kinds of astronomical objects, just like totally out of nowhere, like for for headlines. No, I don't think we see that. Is there a woke math? No, I don't think we see that. When we look at the Soviet Union, again, centralized, system, but still with many oligarchic, had a party, right? But it also had a leader. And you look at the Soviet Union, the math is fine. The math is perfectly fine. The astronomy is fine. Soviet astronomy, no, they're studying the same skies that we're studying. Soviet sociology, Soviet psychology, Marx-Lenin studies. It's all just trash. And so when you look at American expertise, you tend to notice that the fields that are funny, that get weird and kind of screwed up, are ones that involve telling the government what decisions to make.
Right.
And it seems that when you have a field, a way of people thinking that involves telling the government what decisions to make, suddenly you have this marketplace of ideas. And as a believer in oligarchy, you're like, okay, not only do we not have just one expert, we have a whole network of experts. And they're convincing each other. They're always arguing, and they're participating in this adversarial discourse. Yeah, in math, that's what's going on. In astronomy, that's what's going on. In chemistry, that's what's going on. There's no politicized chemistry in the Soviet Union, right? But when it comes to sociology, or like anything that involves advising the government, if you're advising the government to do more, by definition, you're making more of an impact. You matter more. And so what happens in an oligarchy is sort of this kind of currency of the trade becomes impact. It becomes mattering. And so, let's say that you're studying Earth's climate. Back in like 1970, you were just studying Earth's climate. You were just like a weather nerd who was like, oh yeah, let's study the weather in a long term. Suddenly, you're sort of forced into the position where there is this global effect. Does it matter? Is it scary? What's going on here? And I'm what's called a lukewarmist, where yes, this effect is real, but I don't think it's all that important. And there are plenty of very pedigreed climate scientists who are lukewarmists, and let's say Judith Curry, for example. And if you're someone like Judith Curry, you have would be a great person to have on, by the way. If you're someone like Judith Curry, she ran like the whole huge climatology lab for many, many years. If you're someone like Judith Curry and you basically write a paper that says this isn't very important, this is like happening, but there's probably Afghanistan is something we should worry about more. And you're attacking yourself. You're attacking all of your peers. You're saying your work is not very important. You should not be getting a lot of money. You do not matter very much at all. And you're not being a team player. And so in the landscape of the marketplace of ideas, things that say this whole marketplace is unimportant and shouldn't grow its budget next year are vastly disfavored, because basically they're really, really antisocial. And and so that sort of craving, when you're inside the deep state and you have that craving for impact, it has a much more definite form. You're basically looking for funds. There's this whole world of things that write grants, that apply for funds. And so this whole world basically has this enormous incentive to emphasize its importance and to matter and to make an impact. Well, guess who wanted to make an impact? Some virologists. And these virologists were like, going along, doing virology, just being virology nerds, and then SARS happened. SARS happened, and this virus jumped out of a bat into a civet cat, into human beings, and killed a lot of people. Unfortunately, wasn't well enough adapted to humans to start a pandemic. So naturally, if something bad happens, and you're writing a grant, a good way to write that grant is to say, well, this something bad could happen again. Let's study this thing to understand it, to make sure we're better equipped to something if it happens again. We can predict it. We can learn more about this phenomenon. This is important science because this is something real that has affected the real world. Good grant proposal. So basically you write that grant proposal and you're like, I know what? Let's go into like bat caves in China and find all the bat viruses and see if these bat viruses could emerge into humans. And how will we see if they could emerge into humans? Well, we'll screw around with them and try to make them into human viruses. What could go wrong, right? And the ostensible goal, and this was not a Chinese research project. This was an American research project started by a Chinese grad student here who went back to Wuhan and was doing that there. The infamous Batwoman, Xi Jinping, right? But this was American science. I think Americans probably maintain their virology labs a little more carefully. If you've ever been to China. There's this word in Chinese, my daughter speaks Chinese, so she's going to yell at me for screwing this up on there, 差不多, which means good enough. And so you're basically saying, okay, we're going to have this, and that was one of the two things that happened in China. The other thing is, I don't know if you're familiar with the phenomenon of the Chinese paper mill. So in science, of course, which has been subjected to these kind of bureaucratic goals, your goal is to publish as many papers as possible. And so you do everything as you can do to publish high-impact papers, as many as you can. That's how you succeed in science today. In China, it's even much more rigorous than that. It's like, you've got to get 5 high-impact papers in this journal to be the head of your lab. It's like totally quantitative. And so you get a lot of production of basically low-quality papers from China in a lot of different fields, including my field of computer science. And so what you had was basically people going out, virologists going out, finding all the bat viruses they could, screwing around with them in labs in countries that everyone involved in this research had an incentive to exaggerate the danger of the research because they had to exaggerate the importance of the research.
Of course.
The more dangerous your virus is, the more important it is. So basically what you've done with virology by saying the virologists should run the show because decisions about what virology to study should be taken by virologists, naturally you're going to get gain-of-function research because these virologists are basically in this like Darwinian cycle of exaggerating their own importance, and the more dangerous these viruses are, the more important they are.
So it's inevitable they will wind up creating viruses.
They will actually wind up creating the virus that they are then literally hired to solve.
Okay, so
this is the case of Dr. Fauci, right? And so you basically created this system of incentives, to sort of step back a second and talk about how these oligarchies work.
But this is not a sustainable system that you're describing.
This is not a sustainable system, but it degrades slowly. And so what happens is this system was initially populated by these really wise and capable people, the Americans of the first half of the century. Can we say they were diverse? No, we cannot say that. But it was, they were amazing people. They got shit done. They conquered the world. They were a big deal. They were the best and the brightest. They built the bomb, et cetera, et cetera, et cetera. Biggest engineering, hey, libertarians out there, biggest and best engineering project of the world, Manhattan Project.
Yeah.
Government project run like a startup. And the government project run like a startup. How can you can't do that anywhere today, right? And so, you're looking at this system of like, we're going to delegate these decisions to these oligarchs, these experts, these institutions, these prestigious things with the nice fonts and the black letter names that are super competitive and hard to get into. And what's happening is that you're feeding, there's this great Latin phrase, who will watch the watchdogs? I'd try Latin, but I'd screw it up. And then people would yell at me. And who should watch the watchmen? Right? And our answer is, we're going to have this decentralized collective network of watchmen that we're going to funnel all of this toxic, we know that power corrupts. And so we're going to basically act like the early Americans sucked at some things, and one of those things was environmentalism. And so we're going to basically say, you know what we're going to do with all our power pollution? We're basically going to just pipe it into this really big lake. And for a while that worked. For a while, basically you have this field of experts and you say, we're going to take these like intellectuals at these universities. The ideas of like universities telling the government what to do, like in 1900, is ridiculous. It's like they do that in Germany, right? And now it's like assumed, like, my God, no, how would you, like, the government would decide on its own, on it. Maybe the intelligence community does that sometimes. They don't seem to do a very good job of that. No, of course you ask Harvard. And what you're doing is you're basically, when you say, of course you ask Harvard, you're pumping power into these institutions. And what you don't realize is you're polluting them with power And after a while, instead of getting this answer which people have disagreed on and fought over intellectually and been all philosophical about, like the way you're imagining these things, working, no, you're actually just being told what you wanted to hear. And so you have this whole system of who actually makes decisions, who actually makes calls.
It was sort of the dividing line where, Copernicus said, look, the Earth is going around the sun, even though we can't tell that the Earth is going around the sun, but the science shows that the Earth is going around the sun. And then, 400 years later, 500 years later, we built this giant tower, but as soon as somebody says science shows X, people say, oh, that must be true then. And I think that's I think what you're saying is, there's statistics provides a veneer of science in an even worse way than some other kinds of sort of scientific predictions work. I mean, as soon as you say statistically, there is this number, 3.72, and, that sounds very convincing and very scientific. And, then people base a lot of stuff on it. And I think you're pointing out that basing stuff on statistical results is even more hopeless than basing stuff on
No, go ahead.
No, I mean, basing stuff on kind of these cases where you can do theory. And yeah, I mean, it's I think the blind assumption that science knows what it's doing in the modern world is kind of, it's kind of bizarre to begin with, but it's particularly doomed when the science is merely a veneer of science provided by putting numbers into statistics. At least that's my point of view.
Okay, I would say something. I agree that with you, but I'll say one thing is that what we see is coming from statistics is by people who are using cookie cutter type methods in statistics. So one, you have statistical errors, and that has been my specialty. When I was a trader, that was it. It's mispricing because people were using the wrong formula. Otherwise, I had no business, all right? Without Black-Scholes, I would have never had a business, you see. These people, thanks to science, okay, I had a business. If there was no science, I would have never had a business, all right? Because, and the second statement that I want to make is, there exists a very, very, very rigorous way to work with statistics. Okay, but it requires a little more, not relying on these metrics. Okay, taking metrics and stuff like that. See, it requires, because metrics can be gamed, and there is a way to deal with. I call it the probabilistic approach to problems, not the statistical approach. Why use probability? Because probability is more general and doesn't have cookie cutter formulas.
Well, you're saying that basically, if you deal with the whole probability distribution and you look at what happens to the whole probability distribution, you can conclude things.
Or not just look at it. The whole probability ensemble, the concept of probability.
Okay.
You see, the whole methods, probabilistic methods. A probability distribution is a simple a subset of the ensemble probabilities, and there are also things, and I think there's a person in the room here, Trishank, who argues a lot about meta problems. That how can probability, and we realize probability distribution cannot tell you what probability distribution it's coming from. That was the first paper I ever wrote. It's called On the Problem of Not Observing Probability Distribution. You don't observe it. So, and what methodology do you need, okay, and then I said, okay, you can have a hierarchy of distributions. Mm-hmm. That if I've observed a tail of a large deviation, I can rule out Gaussian. Okay, so it is very similar to Popperian falsification. I can rule out that this thing is degenerate. Degenerate means no distribution. If things moving, and okay. If I see something, 10 sigma events, it's much more likely that the distribution is not Gaussian. It's 10 to the 100 times more likely a distribution not Gaussian, right? Yep. Than it being a 10 to the 10, an event of such low probability in a Gaussian, okay? So you can rank them and rule out what it can be, and also use some scientific theories to rule out that human height is fat-tailed. Because if human height were fat-tailed, okay, you'd have most people have to have a mother So you have to have a womb. That's another human height being fat-tailed means once in a while you observe someone who's 1,000 kilometers tall. Okay,
Right.
so this we can rule out on scientific grounds, based on the way humans are built and the way they scale and all of that. So you can rule out. So you can put structure into distributions. So the idea is, if you're going to use probability distributions, use it right. And but the problem is they waste their time on details of things. And then the other thing is, do not go to conclude this section. In physics, you can go from general to the particular and from particular to the general seamlessly. In medicine, you go from the particular to the general, but you cannot go back from the general to the particular that easily. And that's a mistake people make in evidence-based science.
Yes, that's, the problem is people believe in science, and people have a largely religious at this point belief in certain aspects of science. And that's been, that is reflected, for example, in people's need, I think, to say, the medical result is, the evidence-based medicine result is, because they want something definite, and that's the place to get something definite.
At the risk of really destroying many more fields, okay, I think there's a rule. If you need a p-value or if you need a statistical result, not a science. Okay?
Yes.
Because, and that applies to psychology is a lot worse, okay, because psychology is a lot more bullshit, and they have longer papers and fewer results and no surgeons and stuff. And so psychology, medicine, economics, oh my God, all right, and the fields, like financial economics, subfields, entrepreneurship, all that bullshit. So they have, whenever you need statistics to drill a point.
I agree.
Okay,
yeah, I made this point myself.
That it's not a science. Now there are some cases where you can do it properly by saying, okay, I'm making claims about an aggregate, and I can see stuff. All right, they are cases, but most of the population of practitioners or researchers, they don't get it right, and we know from and also the problem is. There are areas that are in fact non-Gaussian. So to tell you that the rule is N of 1, it's a clinical consideration where you have a doctor, patient is clinical. You need to know medicine. N of 100, it becomes a statistical problem. N of humanity with pandemic, it's a tail risk problem. And the three are three different disciplines.
Yeah. Well, look,
and the results you get from N of 100, may not flow down or up. It definitely don't flow up.
Look, my point of view is anytime when you need to use fancy statistics like p-values to tease out a conclusion, the conclusion is deeply suspect. I mean, the fact is people invented all that stuff in the 1930s and so on when they were doing, agricultural statistics and things like this, where it was hard to get a lot of data. In many fields today, it's easy to get tons and tons of data. And, you see in lots of things I do, for example, you can just see, okay, it's not clear what's going on, just get more data. And, then you plot this graph and you can see the whole thing is clustered in one corner or another corner, and you can make a definite conclusion. I think, the issue in medicine, one of the problems is that this idea of clustering things, I mean, it's deeply flawed because people are so different. There are, when you do some clinical trial, you're aggregating together, as your example of steroid dosing and so on indicates, you're aggregating together all these things which may, for theoretical reasons, have utterly different results. But you're just putting them together and you're saying, we'll use statistics, which somehow is some scientifically magical thing to tease out an answer.
But I have one point in defense of one methodology, okay? And I don't know if you've heard about the hydrochloroquine stories with people clustering.
Yep.
They vote Trump, they like hydrochloroquine, stuff like that. And the beauty of having the control group, okay, would have a placebo or not placebo. It doesn't have to be placebo, but having a proper control group, randomly selected individual, you give them a drug versus not. That you notice that hospitals, where hydrochloroquine was successful, have a lower mortality rate effectively had populations that were younger.
Okay.
And your rate of death from COVID doubles every 10 years, approximately, beyond the age of 50. So you realize if you have a 10-year younger population, you're going to have the death rate.
Right.
So, and you can even shoot for younger, as someone I won't mention did. So therefore, their methodology of double blind, or not necessarily it has to be double blind, but the randomized control trial is that you take a population and you want it to be as close, okay, the population that has the medication to be as close to the population that doesn't have it. So you can see an effect without all these things. So there are some tricks that they do that have value, of course. It's just that the results that they get, okay, designed for the general, you need to retranslate back from the general to the particular.
Well, there are other. Yeah, I mean, there are many other problems with clinical trials. I mean, the whole technology of who do you have in a clinical trial is a very bizarre business, because there's a lot of you don't qualify for the clinical trial because, well, actually we think the drug is not going to work on you for this or that reason. I'm sure this happens. Analogous things happen in plenty of finance situations. We won't have you in this clinical trial because you don't qualify for this reason, which is in fact a proxy for the clinical trial is going to fail on you. I mean, I think the interesting case for clinical trials is genuinely personalized medicine. How do you deal with that? Is there any statistical way to deal with that? In other words, if you say, everybody is different, everybody has a different genome sequence, it's going to depend on some unknown aspect of the genome sequence, what happens. Now you could say, well, it seems difficult to maintain this idea that everything is based on statistics if you are actually recognizing the fact that people have an immense diversity of different, medical characteristics.
This I agree fully with you, and it's a problem that needs to be solved outside that Fisher, all these theories that came out of the bad statistical methods. They came from heuristic statistics rather than understanding the fundamental probability thing, and they have their heuristic. Right, like if it's n of 30, then it's Gaussian. Therefore, this, and a lot of mistakes. And I see even further mistakes. Like, for example, correlation. Correlation is a metric that has no meaning, all right, outside linear relationships.
Mm-hmm.
And I have a paper called "Fooled by Correlation" on on the web, waiting to be fixed. And that fooled by correlation papers, supposed to show a bunch of things, like, for example, a lot of paradoxes that people don't know. Okay, that it's not transitive, and the mistakes are made usually by psychologists, because in medicine is gold compared to social science. Social science is a mess. It's a complete mess.
Well, one of the things you say that, but one of the things I've noticed is if you look at things like statistics of people visiting websites, okay, and you look at the detailed behavior of people when they visit a website, one thing that I've been really struck by is you look at curves for, the time interval between people clicking this and clicking that and so on. They are wonderfully smooth and quite tight curves. In other words, there are some principles of human behavior which we don't happen to know, but which are surprisingly predictable. So in other words, you might have thought psychology, things like that, will just be a mess because nothing is predictable. I think that's not true. I think we don't know how to predict it, but I don't think it's true that there's nothing there, that there's no possibility of a kind of Newtonian science of those kinds of things. I think there can be, we just don't know what it is.
Maybe I have a little nasty statement in Skin in the Game, where I explain two things. I said anything you hear about statistics that works, that is not bullshit, Okay, you can find it. You should find it in Erasmus, who compiled the classics about 500 years ago. All right. So if you don't find it in Erasmus, it doesn't exist. So once a statistician jumped on, one psychologist jumped at me and said, "You idiot, cognitive dissonance." All right, that's a new concept. It didn't exist. I said, you can find it. Erasmus, because he's a portal to the classics, or Montaigne or someone. Of course, you find it. It's the sour grapes.
Yeah. Well,
Which
right.
way precedes the Greeks? The Greeks, because a lot of these Greeks, fables existed already with the Assyrians.
I didn't know that, but it doesn't
So yeah,
surprise me.
like I found a bunch of them in Assyrian texts that precede the Greeks by about 800, 900 years, and they're not that well known because it's a narrow field seriology.
It's an interesting fact that human nature has not changed throughout recorded history.
So our ancestors know so much more in that field. You see, they may not know physics, but they know a lot about things. So I said, whatever is not there, okay, odds are it's bullshit. And as we know, there's all these tricks that psychologists try to figure out about humans. The other statement I said, if it's not in Erasmus explicitly, all right, it must be known by used car salespeople. All right, and effectively, all these Richard Thaler theories and stuff like that were well known by advertising agencies. How to manipulate people, and it's known. And the third category of people who know it, so it said Erasmus, used car people, and magicians. Magicians had long before them known about all these optical illusions and illusions that you can have attentive, all these things that psychologists know. So basically, some fields have brought nothing to our knowledge of human nature, if not a degradation, because they give us about 55% of the papers don't replicate.
Well, right, but one of the questions is, science. We were starting off talking about science and what science could do, and there's a certain model for what kind of a thing science can do. And there's a question when it comes to psychology, for example, are there things of a kind which science, as we currently imagine science, can do or not? And is it, is psychology kind of a thing? Could there be a Newtonian type theory of psychology, which we just don't happen to know what it is? For example, or to take a simpler case probably is immunology. We actually are very ignorant about how immunology works. And, there could perfectly well be kind of a Newtonian-like theory of that. We just don't happen to know what it is yet. And there are other things where I suspect there fundamentally can't be a Newtonian-like theory of those areas. I mean, I think that what...
To have a theory, I mean, to go back to what you call Newtonian theory, if I understand, let me rephrase it so I understand it. Okay, that's the way I understand anything. Newtonian theory means that you don't have to catalog or describe every apple falling from every tree. Okay,
yes.
Particulars. I can have a general model by which I know how apples fall and reapply it to how apples fall.
Yes.
They all must fall under the same, equation. They all must fall the same way.
Right.
That's what you call Newtonian theory. Okay.
Yes.
And that's exactly the mistake that people are making. They think they have Newtonian theory when they have a evidence-based thing.
Yes. And they don't.
Because they're taking the average apples, whereas Newtonian theory applies to every single apple. You see.
Right. But notice.
Yeah.
Right. But notice an important point. One of the things that physics has achieved is it's built these pretty big towers of theories. That is, you start off from some underlying set of principles, and you build this whole tower of this follows from this follows from this, et cetera, et cetera, et cetera. Mathematics has probably built the tallest such towers, but physics has built fairly tall towers. In medicine, I don't think they build towers. If they did, they would all fall down. And what you're describing, this function of an average of a function, and so on, that's the lowest level effort to build a tower, and it will collapse. I mean, in other words, you could say, that's a difference between a kind of science where you can build a tower and a kind of science where you have one, fact result, but you can't build on top of it. And probably some of the errors you're describing are attempts to build on this kind of sand-based foundation that you get from taking essentially the statistical results in medicine.
We wrote a paper saying it's called On the Error of Making a Single Point Estimate when you have a probability distribution. You see, so the actually, and the error is made by, and I said the error had been made by two people, by the people who wrote these models making a prediction. All right, because it's a distribution that has so much variance, you can't make a single prediction. You describe what can happen, and it's fat-tailed. Okay. And the second, so therefore you don't observe the average. You see, you observe realization, not the average. And the second error is made by those who criticize them by saying, "Oh, your projections didn't play out." You see, so both were wrong. So we wrote a paper called on. It was a fight we had. It started with a Twitter, comment, which degenerated into a paper with my colleagues. We have discovered that the fattest tailed random variable on the planet is by far pandemics. And you take 500 pandemics, and we know they're fat tails. You remove half, you remove this, you find fat tails. It's very robust. Now, that's a way to approach the process by saying this is scientific result that is fat tailed, and the same scientific result tells you, right, that your methods of trying to look for the mean don't work. Okay. Because this we call the dog being wagged by the tail. Okay, so because it's all the information is all in the tail and you don't see the tail. So when we made that statement, then we had a fight with Ioannidis. He said, "Oh, let's wait for scientific results to come before we take action on a pandemic." He said, "Yeah, let's wait for a car accident before we put the seatbelt on." This is the same kind of statement. So the paper, and I think I sent you a copy of that paper because I did the graphs with Mathematica, right? And so it was, and I like the rest. I'm not as good as Diego here in the room with Mathematica, but I'm one day I'll get close to Diego. All right. So with the graphs anyway. So I did the graphs by showing an example of if I have a log normal distribution. Not even a fat-tailed distribution, okay, with a high variance log normal distribution, that you can have 95% of observations below the mean. Okay. So how can you make a prediction? You're going to be 95% wrong, all right, if you get the mean right. You see, so, and the second point, which is in dynamics of things, is that in a dynamic process, in other words, where we have the feedback from people informed of decisions, is that you say the predictions are either self-canceling or self-fulfilling. Yeah, so in this case, they were largely self-canceling, because it's like if you predict a terrorist attack, it won't happen, right? It's self-canceling. But in the case of people had caution, and it's self-canceled. But however, I'm going to say one thing about the models used, is that I saw you and Diego and your son make these cellular automata models that were vastly more robust. So in one afternoon, you guys nailed the model or trying to do these things, vastly more robust than everything they had in academia. So
I would say more robust. I would say more revealing, at least the things particularly Christopher worked on. The main thing was that you could tell you couldn't tell. That is,
so there, hence, I guess the subject of today, which is the computational irreducibility.